Assalamualaikum. My name is Shafiq and my metric number is TA19161. My group will explain about the fabrication of additive manufacturing process to build ceramic or metal parts, example of LTCC. The introduction about this process is about hybrid additive manufacturing revolutionize the fabrication of ceramic or metal parts. It overcomes limitation of conventional method by enabling automation, integrate 3D metal circuit, and thinner ceramic layers. Fabrication of stereolithography and robocasting deposit ceramic and metallic structures. Test part validate its mechanical and electrical behavior. Approach offer potential application in aerospace, automotive, and energy sector. The literature review essay reviews the current research the development in hybrid additive manufacturing for low temperature coherent ceramic LTCC component. It explores the limitation of conventional production method and the potential of combining stereolithography and robocasting to overcome this challenge, allowing for improved characteristics and greater design freedom.
It's Muhammad Luqman bin Zadi, TA2001. I will present about the methodology. Methodology about the presentation of the hybrid machine has a stereolithography and micro extrusion are the two methods chosen to the max class or alumina and silver LTCC component. The principle of process stereolithography and the robocasting. Next figure assembly for the production of PI material objective combining robocasting and stereolithography process. The presentation of different geometry studies for the A uncovered track, B embedded track connected to surface by vias, C armor vias, and D for oblique vias. The method is represented in dark blue and the subtract in the light grey, vias in red, and armor in black. A hybrid method can be used to generate this geometry, which can then be characterized in the macro region. So it's obtained a part with dimensions that are as near to those designed by simulation as possible. Figure is about the linear geometry for the hyperfocus illustration and that microstrip resonator with the dimension given in micrometer range. For the ceramic paste for the dielectric substrate, the characteristic for the elasticity substrate adapt to application of high frequency. First is low dielectric constant between 5 and 20. Second is low dielectric loss between 10.3 10.4 and dielectric constant temperature, the coefficient is close to 0. Selection of ceramic powder, also the choice of binder additive, the depth mixing and preparation. For the metallic paste for the tracks and vias, glass was selected to enable the disinfection of the alumina or glass mixture for the dielectric material at a temperature of 850 degrees Celsius of binder and additive. After that, mixing and preparation. And lastly, measure the electrical conductivity of the metallic paste. Process optimization. We have three: ceramic printing process, metallic printing process, and hybridization. Ceramic printing process and metallic printing process have two: deposition parameters and optimization iteration. And for the hybridization, two: integration strategy and parameter and technique. For the processing, we have four processing. First is debinding, second is sintering, 3 is surface finishing, and lastly for the fabrication.
My name is Muhammad Najmi bin Yusof. TA20003 will proceed with result and discussion for printed part. Stereolithography is used to print substrate with a layer thickness of 50 microns. Robocasting is applied to create tracks with a printed speed of 10 mm per second and a nozzle diameter of 100 micrometer. Optical microscopy is used to observe the track before any thermal treatment. Optical microscopy allows for the examination of track characteristics such as shape, dimension, and quality. A thermal cycle is ellipsometric analysis was performed on various glass alumina mixture to determine the optical ratio for the substrate material. The glass transition temperature of the tested glass was around 815 degrees Celsius and the softening point was at approximately 870 degrees Celsius. Higher concentration of glass led to greater shrinkage, with pure glass exhibiting the highest shrinkage of 40%. Two relative densities of sample with different glass alumina ratio were measured after sintering at 815 degrees Celsius for 1 hour. The mechanical properties of the substrate were evaluated after the debinding and sintering process. The relative density of the LTCC substrate without the silver track measured using ethanol as inhibiting liquid. The measured relative density was found to be 97%, indicating significant densification and near complete consolidation of the substrate.
Ini is Muhammad Rusdi Bihasan, metric TA19174. Discussion. Where are the limitation of this process? Material compatibility, the strong hub graph, robocasting, possible, ceramic and metallic material are needed for the hybrid process, or LCC material may be compatible with this or additive manufacturing process. What are the advantages of the process? Design, stability, complete 3D geometry can be produced with additive manufacturing. No possibility way of conventional production can. What is the main material used in the process? Ceramic material. The ceramic substance utilized in LTCC component is often a mixture of the glass and aluminum. Glass component have to achieve the optimum sintering behavior. Electrical properties and alumina offer outstanding mechanical and thermal quality. Metallic material. The technical application and electrical certification determine the metallic material used in LTCC component. High conductivity. Silver, copper, gold are user material. The condition pattern, views, and the electrical characteristic LTCC structure and user metallic material. Industry uses this process. Electronic and telecommunication, automotive, aerospace, energy and power system, medical device. Where this process be more efficient in the future. For LTCC component, every additive manufacturing process have the benefits of automation, complete 3D metal skirt, flexible ceramic packaging, and genus lawyer. User in the medical, aerospace, automation, energy, electronic, and telecommunication industry.
Today I want to present about conclusion and recommendation. For the conclusion, a hybrid machine combines stereolithography and robocasting to create monolithic multi-material component. The process involves constructing the electric substrate and depositing metal track in low temperature fired ceramic. That's called LTCC. The finished product have mechanical qualities comparable to conventional techniques. Additive manufacturing approach is for constructing complex construct like metallic armors and oblique via, making it suitable electronic component like LTCC and HTCC. For the recommendation, patented hybrid machine show that it is possible to make LTCC part with desired mechanical qualities, but is still room for improvement. Research should keep looking into the process setting, material formulas and design to improve how well and reliably printed parts work. Second point is make sure the material used for the clay and metal is compatible with the process being used for additive process manufacturing. This means taking serious their temperature quality, how they shrink and how they disintegrate. To good bonding and functional stability in the end parts, it is important the materials work well together. Finally, for the recommendation, improve the sharpness, measurement, accuracy, and surface finish for the hybrid production process by making small change to every aspect of it. This could mean adjusting the setting of both the stereolithography and robocasting process and finding the best way for them to work together. That's all from me. Thank you.